There are 5 major types of chemical reactions. One type is the synthesis reaction. In this type of reaction, 2 or more reactants combine to produce a single product. You can think of it this way. This substance, we'll call it A, can combine with another substance, B, to produce a new substance, AB. So here's how that looks. And an example would be the formation of salt, where you take 2 sodium atoms combined with a chloride molecule, and you get 2 salt or sodium chloride molecules. Here's another example that produces magnesium oxide. And magnesium oxide is often used in roadside flares. This reaction between magnesium and oxygen produces magnesium oxide and a lot of heat and light. One more example is when nitrogen reacts with oxygen, you get a new compound, nitrous oxide, and this is often used by dentists for patients to inhale to alleviate some of the pain they might experience. And it's also used to give really spiffy motorcycles. People sometimes add nitrous oxide tanks and canisters so that they can make their car or motorcycle go extra fast. More often this would be used in a racetrack situation, obviously not safe on the road. Let's talk about decomposition reactions. This is the breaking down of a compound into smaller compounds or separate elements, and it's the reverse of a synthesis reaction. So a really simplified kind of model of that would be something like this, where you start with a compound and it breaks down into its 2 subcomponents. So it looks like this. Here are some examples. You could have sodium chloride breaking down into sodium and chlorine, which is obviously the reverse of the previous reaction we looked at. And you could have water. This should be a subscript 2. Water breaking down into its components, hydrogen and oxygen. And this can be done easily in the lab using the electrolysis equipment, where electricity is just sent through the water and you can collect oxygen and hydrogen on the 2 sides here. And since we have twice as much hydrogen and there seems to be more gas over here, this is where the hydrogen gas would accumulate, and this is where the oxygen is shown accumulating. This is called a Hoffman electrolysis apparatus. Single replacement reactions. In a single replacement reaction, a reactive element and a compound react to produce another element and another compound. So in a single replacement reaction, you might start with a substance A, and it reacts with the substance B, C, and at the end of the reaction, you have replaced B with A. So it's called a single replacement reaction. Here are some examples. You can see that there's 1 element here, 2 elements here, aluminum, copper, and chlorine. You end up with copper being on its own and the aluminum and chlorine combining with one another. And in each one of these you'll see the same pattern. Single element recombining with another and displacing one of the other elements. And once again, this should actually be a subscript here. So once again, this should be a subscript here, and we have the fluorine replacing the iodine in sodium iodide to form sodium fluoride. So that would be a single replacement reaction as well. Double replacement reactions. In double replacement reactions, 2 ionic solutions react to produce 2 other ionic compounds. At least one of the compounds produces a precipitate or a solid. So in this case, we have substance AB reacting with substance CD to give us substance AD and substance CB. So in a way, you can think of them as just sort of changing their partners. Here's how that looks. AB plus CD gives you AD plus CB. So if we think of P as A and NO3 as B, and if we think of Na as C and I as D, we end up with CB and AD. Look at the next one. Think of Na as A and OH as B. Think of Fe as C and Cl as D. We end up with A, D, and CB. So they've recombined. Double replacement reaction. Neutralization reactions. These should be familiar to you. An acid and a base combine and neutralize each other to form a salt and water. So you should be familiar with this reaction. Acid plus base gives you salt and water. And we symbolize the acid this time as H with whatever else is added onto it, because the acids that are inorganic begin with H. And we symbolize the base as M, OH, and M stands for the metal ion, and OH stands for obviously the hydroxide that we see in all bases. And what ends up happening here is that the metal combines with the non-metal from the acid, and you get the salt. And what's left over is the hydrogen and the hydroxide, and those two combine to form water. You can see the same pattern with the one down below here. Hydrogen and hydroxide are going to form the water, and the other parts are going to combine to form the salt. Combustion reactions. Combustion reactions are exciting to watch because they're very rapid reactions of a compound or element that reacts with oxygen to form an oxide and to produce a lot of heat, and often there's a lot of light involved as well. So here's an example. If you have some sort of a hydrocarbon, and if you recall, hydrocarbons are materials that contain hydrogen and carbon, and we think of hydrocarbons often as fuels. When they react with oxygen, they produce carbon dioxide and water every time. Okay, so here's an example. Methane reacts with oxygen to produce carbon dioxide and water. We have another example of a hydrocarbon, and oxygen produce carbon dioxide and water again. There's our carbon dioxide and water, always the product of a combustion reaction. When you burn something, you get carbon dioxide and water. And here's one that happens inside of us. You can also do it externally, but when it happens inside of us, it's a lot more efficient. We burn glucose in the presence of oxygen, which is why we breathe, and we produce carbon dioxide, a waste product, which we have to get rid of by exhaling, and water. You can actually see the water in your breath when you exhale onto a piece of glass. Okay, so those are the 5 major types of reactions. There's a really short video on YouTube that you can watch that shows these 5 reactions. And there's also a really neat little link that I've put on here that shows you visually how you can think of the different chemical reactions, and these little cartoon pictures that are analogies to each of the different types of reactions. So have a look at those.